We've got a good group here. Thanks for joining, everybody. This is an MLOC group event. This is a MLOC group webinar. MLOC group stands for Million Lines of Code. We're an open and agnostic community that focuses on the challenges that come along with developing, deploying, managing some of the biggest applications in the world. So apps with millions of lines of code. You can find us at mlocgroup.com. So it's MLOCGROUP.com. And there's some additional events posted up there, and there'll be lots more that we're going to post in 2022 as well. This is actually only our second official event. We did a live event, like an after party at CPPCon a few months ago. Had a big turnout for that. And this is our first official event with some real content. So thank you, Steve, for joining to offer that up today to everybody. Speaking of today is the 13th of December. I am Jim Schultz. I'm the head of community at MLOC Group. Today's talk is going to be led by Steve Spear. He's a senior lecturer at MIT, also the author of The High Velocity Edge, also a principal at Seed2Solve LLC. So lots of hats Steve wears here, but I've seen Steve speak before at another community that I manage, and very excited to see him speak here today. The topic today is, Steve, you gave me a really long title and I shortened it to Innovate Under Extreme Stress, but the official title of the talk today is Accelerating the Learning Curve, Harnessing the Enterprise's Intellectual Horsepower for Innovation in Periods of Extreme Stress. Very long. I think when I start asking for titles now, I need to say 3 words or less.
Oh, I thought you asked for blurb.
Yeah, was that the blurb that I just read?
Could be.
Before we get started, I do want to acknowledge and thank MLOC Group's corporate sponsor, which is Incredibuild. Incredibuild works with many MLOC Group member companies. They have a solution that reduces build times and test times. A really cool technology. And as soon as I'm done talking, I'm going to paste a link to Incredibuild in the chat as well. More importantly, when we get together for live events, Incredibuild buys all of our food and beer. So big thanks to Incredibuild for being our sponsor.
Is Chevy checking the door, stoop for a package?
Maybe.
A little Sam Adams outside. Sorry.
Yeah, no problem. Yeah, we thought about doing that kind of stuff for when all this first started, doing virtual events, virtual happy hours, but it's just too logistically confusing to try to do that. But I'm going to post a second link into the chat as well. The other one is for our next MLOC Group webinar, which is going to be next month. Matt from Roblox is going to speak to us about, he actually has a presentation entitled MLOC, so it's all about managing big applications. So very excited for that one as well. So with all of that, it's now time to introduce our friend Steve Spear. If you have any questions during the talk, please feel free. We want this to be very casual and open. That's why we do this as a meeting rather than a webinar. If you want to come on video, you want to come off of mute and ask questions, type your questions into the chat. We want to keep this as interactive as possible. This is a true community in the sense that we all want to learn from each other. We'll wrap up the event too with some additional Q&A. If you have any comments or questions or anything like that, you can also ask then. So enough of me, Steve. It's now time for you. I'm going to virtually pass the mic to you, and you should be ready to roll.
All right. Hey, that's great. Thanks very much for the invitation to present today. Everyone, thanks for making time, plus or minus around somebody's lunch hour. If you have any questions as I go, so interrupt if you want to just yell over me on the microphone, that's fine. Occasionally, I do stop and take a deep breath. So when I'm doing that, that's a good time to interrupt. Also, I've got the chat up here, so feel free to throw something into the chat and I'll do my best to scan. The reason I'm emphasizing so much this idea of interrupting today, sometimes I was saying to Jim earlier, when I'll do a presentation, there's a whole big theme and then dig down into one particular point and really detail it out. Today, I thought I would take a shot at just covering a lot of ideas, all related to this idea of innovating under times of stress. Given that I wanted to do more a surface treatment, if there's something that's just not clear as I go by, call it out. Also, if there's something that really merits some further conversation and discussion, call that out too. Like I said, I don't want to avoid depth for the sake of avoiding depth. So anyway, feel free to interrupt. In terms of goals for this presentation, the thought here is, innovate under extreme stress. So when we're under a lot of stress, typically, we're thinking about the scream. So the goal, if nothing else on this presentation, is we give some techniques to turn those frowns upside down, right? So we're trying to upside down the frowns. And let me explain, let me build into this a little bit. So first of all, when we talk about innovation, typically we're not talking about, what we do as an individual. Typically we talk about what we do on very, very large scale, like, sending manned missions to the moon or Mars or wherever else we're going to send people. We typically think about doing things collectively. So let me just start with almost a rhetorical question at first, which is, why is it we even form organizations in the first place? The LTDs, the LLCs, the INCs, et cetera, et cetera. Why do we try to get people literally, figuratively, especially COVID, more figuratively than literally, why do we try to get so many people under the same roof? And what I want to offer is that the reason we do that is that life throws us problems, which are just we can't solve on our own. And unless we pull together a lot of brains just for the processing power and for the subject matter expertise and the variety of stakeholder interests, et cetera, unless we do that, unless we get a lot of people under the same roof, we can't solve those problems, which then gets to the managerial problem, which is, what is the job of management then? And I'll argue, and I'll say it vehemently with a lot of conviction, that the job of management is to create the coordinating mechanisms, the social circuitry, the social overlay by which the contributions or the efforts of many, many individual people working within their domain, working within their silo, working within their subject matter expertise, the efforts of many individuals get integrated as contributions towards some common whole. That is why we form organizations, and that's the job of management. So then it gets to the next question of, why do we have problems then? Well, if the reason we get together in the first place is to solve problems collaboratively, collectively, creatively that we can't solve on our own, and we still have problems, what that says is that whatever we've done as managers, as leaders, is that we've managed to integrate the efforts of many people towards the ability to still have a problem, that we haven't figured out yet how to integrate the efforts of many people to the point that we actually have a solution to the problem that's plaguing us. So anyway, when we start thinking about problems, and very often problems are framed as technology problems. We don't have a vaccine, we don't have a test, we don't have a robot, we don't have this thing, we don't have that thing. We typically think of technology gaps as needing technology solutions. Yes, and at some point we do, right? Got the new virus variant running around. Thank goodness we have the technological solution of Pfizer, Moderna, Johnson & Johnson, et cetera, AstraZeneca. But the reason we don't have technology solutions when we need them is because we still have a management gap. We haven't figured out yet how to bring the individual efforts, integrate them towards some common collaborative collective purpose. And so what I want to do today, like I said, today is structured more as an overview rather than a deep dive, but I want to highlight what are the various ways in which we leave management gaps in place, and then how might we address them so that we've closed the management gaps, we can better integrate the contributions of many individuals towards common purpose, and boom, zam, there goes the technology gap. We've turned the technology gap into a solution. So working down this list, are we aligned around an external problem? Are we aligned internally to solve the same problem? Are we experimenting versus just winging it, trial and error? Have we scaled our problems in such a way we can actually wrap our brains around them versus getting overwhelmed? Have we actually worried about developing our talent pipeline? Have we tapped into everybody's brains, and what I talk about engaging the operating edge, or are we just trying to solve problems by this concentrated elite up there, out there, wherever it happens to be, the R&D center, the headquarters, this and that, but terribly disadvantaging ourselves by not taking full advantage of all the brain power in our enterprise. And then I'll finish this up. Maybe I should start it with this idea that to do all these things, it's necessary to create a protected space, because if we don't, then what we're going to be trying to do is do all these things around new problems, new alignments, this thing, that thing within our existing business models, our existing norms, our existing processes, which will just have this immune response effect. So anyway, that's the setup here. We organize, we gather people together to solve big problems that we can't solve individually. If we still have problems left in place, it means we've done that integration less well than we need to, and some ways in which we can do that integration poorly, or the flip side, do it well, is around some of these points. So anyway, let me talk first about external alignment. So when we start thinking about have we actually hooked onto a problem, now think about the failure mode here, right? You get this a lot. People say, oh, we're going to do a great new technology. We're going to do manipulate the gene. Oh, we've got autonomy. We got robotics. We got artificial intelligence. We got machine learning. Boom, 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 boom. And then you say to people, well, what problem are you actually trying to solve? Oh, no, but we're going to develop some phenomenal machine learning. Yes, but to do what? To accomplish what? To alleviate what symptom? To solve what problem? And I'm willing to bet that if you look at your own experience, whether it's internal to your own organization or just things that you scan around in the environment, you see a lot of people who are like so obsessed on developing a technology that for the life of them, they cannot explain what problem they're trying to solve. So now let's think about this for a second. What are some necessaries? So one, when we start thinking about what is the problem, defining the problem, first of all, what's our time horizon? I mean, is the problem like it's at my doorstep right now? All right, that's a big deal. Second thing is, might be not right now, but it's a tomorrow problem or a next week problem. It's not right now. My underwear is not yet on fire, but it might be very soon. So that's an intermediate problem. And then there might be a slightly longer term problem. It's sitting out there weeks, months. Once we start getting into years, anyone here can predict what's going to happen in 5 years? Or let me ask you this: anyone 5 years ago predict, I don't know, COVID, iCloud, iPhone? All right. So anyway, let's think about this long term, 3 years. So one, we have to figure out what horizon are we focusing on? What horizon are we focusing on? Second thing, what's the problem? Have we actually gone out of our way to sit down and figure out and have a conversation, a discussion, an exploration of what is the problem we're actually trying to solve? And again, you see this all the time. People saying, oh, we need an AI strategy. Why? I mean, I'm not speaking out against AI. It's sort of a nice thing. I like the little Siri thing on my phone. But why do you need an AI strategy? We need a machine learning strategy. Yeah. Again, why? I mean, because if you can't say why you need a machine learning strategy, basically you're saying, we need to spend a lot of money to keep a lot of computer geeks really happy, spending down typing away. All right. So anyway, what do we need to do in terms of external alignment? One, set our time frame. Two, define our problem. We should probably spend a little bit of time figuring out who the stakeholders are. And what I want to say about the stakeholder thing, it's not just who's suffering the problem. So that's actually a very important thing to figure out. But also, as we try to figure out how we're going to solve the problem, how do we figure out who's got a bit of knowledge that we might want to pull in, who's got a bit of expertise that we might want to pull in, someone has a bit of expertise that we want to pull in. And I'm sure you've seen these failure modes, right? Where someone says, oh, we got a big problem we're going to solve. All right, yeah, and then we're going to work on this thing. And then it's only at the end where they start showing their big, brainiac solution, that they start exposing their brainiac solution to stakeholders. And then people say, I wish you'd asked me a week, a month, a year ago, because what you've done, it's very creative, it's very clever, but it's actually of very little value because you didn't incorporate what I knew either about the problem or what I might have contributed to the solution. So anyway, what's our time frame? What's our problem? Who are our stakeholders? Now let's get just onto an example of this as to why defining the problem is so important. So look, I think a lot of you know my background was trying to explain why Toyota was kicking the butt out of its competitors. And, I like to pick up on Toyota, not only the pairwise comparison, Toyota versus GM, I'll do that a little bit later, but also Toyota before, Toyota after. I mean, Toyota's not always perfect. Their recovery time is phenomenal. So when Toyota was just really crushing it with the mid-market, mid-size, affordable reliability offering, think Camry, in the 1980s, they said, oh man, we're leaving a lot of cash on the table with luxury. So what they do, they said, what's luxury? Luxury is leather, luxury is wood veneer, luxury is chrome. And so what they did is they took a car, a full-size car, what was similar then to what the Avalon is now, and they blinged it up. And wouldn't you be surprised, but the sales were lousy. And you can see the bling up here. It's not only did they put the car with all the bling on it, but they put it in front of a 2-car garage, fancy driveway, etc. They're trying to scream out as material well-being as their definition of luxury. It turned out it was a bomb of a product for the simple reason that no one is going to a Toyota dealer to get bling, right? I mean, you're going to Toyota to get reliable affordability or affordable reliability, whatever you want. You're not going there to get bling. So the Toyota folks said, man, we didn't understand the problem we're trying to solve. Now, they came back later on with Lexus, and you all know Lexus is like incredibly successful, best-selling, luxury brand, blah, blah, blah. It's a phenomenal brand. But it wasn't because they figured out how to better bling a car. So here's the story with Toyota. They went back and said, the reason we bombed with this car on the upper left is not because we were technologically unsophisticated. It's because we didn't define the problem first. And so what they did was they said, we don't even know what the meaning of luxury is, not from the American perspective. So they sent the design team to go live in Beverly Hills. I think it was like a 6-month assignment or whatnot. And these folks, they ate here, they shopped there, they stayed here, they golfed here, boom, boom, boom. Like, hardship pay, I'm sure they didn't get on that one. But the point is that they're out there in Beverly Hills trying to figure out, why are people paying so much for things that, all right, look, the thread count on the t-shirt is maybe better than the one you're going to get at Banana Republic or the Gap or the Navy one, whatever. But it's not that many more threads in the counts. They're saying, so why are people paying so much? And then it hit them. It's not the product only that they're paying for, it's the whole experience. And so Toyota engineers come back from this hardship out in Beverly Hills where they spend 6 months. They come back and say, wait a second, the problem we're trying to solve with the car is not putting bling on it. It's making the whole experience of buying and servicing and owning a car and leasing a car. It's to make it a very nice, respectable, silky experience. What becomes the business model for Lexus? It's not BMW, it's the Four Seasons. And you'll see this. So when you go look at a Lexus car, you say, hey, it's a nice car, but it's not a BMW necessarily. And, it's kind of like a Toyota, but the sales and service and maintenance experience is a whole different thing. It's Four Seasons. So anyway, where does that come from? It comes from first leaning deeply into the problem space and first coming to a meaningful definition of what problem you're trying to solve. In the case of Toyota, the first guess was they were solving the bling problem, a technical problem. And they realized they were really needing to solve an experiential problem, the Four Seasons problem, and boom, you get Lexus. Anyway, just to carry this over real quick, I had a chance about a decade ago to work with an Army unit called the Rapid Equipping Force. And the thing goes something like this, which is Iraq, Afghanistan. This is not the place where you're going to be deploying M1 Abrams and lots of all these big, huge, gigantic systems, which were meant to, challenge Soviet forces across the level of Central European nation states. There's like all these oddball, idiosyncratic problems going on. The genesis story for this REF, the Rapid Equipping Force, was the problem of soldiers sticking their head in a cave looking for something dangerous or someone dangerous or something like that, and being able to do it safely. And the REF started generating all sorts of really cool technological solutions, robots that you could fit in a backpack, little intelligence, surveillance, reconnaissance balloons that you could fly out of a squad could fly rather than a battalion or a brigade, giant dirigibles, whatnot. But when you say is, all right, well, that's a lot of cool technical solution. But where did the REF come with this very rapid pipeline of solutions to problems that troops were having in the field? Well, it started with leaning into the problem space. And one of the big innovations of the REF was not only the technological innovations that it was able to deploy very, very quickly out into the field, it was the procedural innovation of forward deploying scientists, forward deploying engineers, where they could be in rapid contact with troops as they came back from patrols, as they came back from missions, and they could have the conversation very quickly. Hey, when you were out there, what made that more difficult than it otherwise might have been? And then just to maintain this very tight development of ideas, so they had the proximity into the problem, and then this connectivity. So what this is like a Connex container, sort of half-size one, outfitted with three-dimensional printers and numerically controlled machines and internet access to libraries, this thing and that thing. And again, what was the point here? It was to, with the ref, they defined the time frame, which was get capability downrange in weeks, not months, years, or decades, like for big, massive programs of record. That was the time frame. Who was a stakeholder? So it was troops in field, downrange. And then third was what was the problem? And they kept redefining the new problem, new problem, new problem, new problem. So anyway, point one is where we often fail is that we don't go through the extra effort for first defining the problem space where we're trying to actually deliver innovation. So that's point one. Now, let me move on. And again, I apologize because we're going, kind of quick. Like I said, I want to cover a lot of these. Second problem is we see this a lot. And, and again, this just gets back to the predicament or the conundrum, right? The conundrum is that the reason we form an enterprise in the first place is we need to get a lot of brains under the same roof to solve towards the same common problem. Now, what's the problem when you put a lot of brains under the same roof? Silos, right? Because, you got these people who are defined by one discipline, these people defined by another discipline, these people, this, you got all these different silos going up. And then if you're not careful, not only do you have silos, you get the silos within silos within silos where, what I said, well, what I'm doing is very different from what you're doing, even though otherwise everyone from the outside thinks we're the same. So just real quick spin on this. And if anyone's interested, I got a paper we've written about that, email me and we can pop it off. Or let me just put into the chat real quick. We even have a little video to this. So if you pop into c2solve.com/resources, we've got a little video on this next case. So anyway, internal alignment. So here's the background is I was working with some folks in drug development, pharmaceutical company, and they're bemoaning the fact that unlike the chip makers, where every year you get twice as much power, twice as much speed, boom, 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 half the space. In pharmaceuticals, it's going the other direction. It takes more time, takes more money to get fewer drugs out the door. And so they were asking the question, why is that? Why is that? Why is it taking us so long? So anyway, the focus of this case, and I'm going to give about 3 minutes to what was a 3-year project. So check out the link if you want. They focused on a particular piece of drug development way upstream, something called hit to lead. High throughput screening by biologists gives you some indication that maybe these molecules might be therapeutic for this type of disease by attaching onto a protein in this particular fashion. And then it's up to these chemists to take those hits, those kind of like, hey, hints almost, we should call them instead of hits, and develop into leads that are worth further development. And when they started looking through how they did this process of hit to lead, I mean, the big thing was this cycle of, I got it sort of indicated in the upper left-hand corner, this cycle of going through, hey, I've got an idea. We call it a design, right? Hey, let's actually physically make that thing, synthesize the molecule, and then test it. And then as we go through these cycles of design, think, make, the physicality, and then test and get feedback on this thing, they said, that's how we go ahead and refine and iterate and cycle through taking these hints or these hits from high throughput screening and get something that can go into lead development. So wouldn't you know, when they said, well, how long should it take us to go through these design cycles? And they said, well, let's take a look at some, successful programs in the past. And they looked at, going through design, hit, lead 3 times. And on paper, if you looked at the time chemists spent here and biologists spent there and this thing and that thing, it was like about a 51-day estimate for 3 cycles of design, make, test. And when they actually looked at the calendar time, though, not like the timestamp time, but the calendar time, it wasn't 51 days on these programs. It was like double and quadruple what was going on. And I said, how can that be? Why, because if you think about this, and we got Carl on the line, so think of this in a factory sense. It's like we draw a process flow, and something goes from step A to step B to step C, and boom, it's done. And what we discover instead is things don't go from step A to B to C to D. What they do is they go to step A, and then they sit around for a while, and then someone drags them off of a rack, and throws it into step B, and it doesn't go to C. Then it goes back into inventory and sits around for a while. And it was exactly the same thing. Now, this is for ideas, not for physical material. It was the same thing. It was like, put the thing on the rack, let it sit there, collect some dust, age a little bit, become increasingly irrelevant, take it down, polish it up, work on it, put it back, right? And I said, well, why is this happening? I mean, there are people who need our solutions. And when they started looking what was going on, and this is when I want to give a lot of credit to the senior chemist on this, someone named Beth. When Beth started looking at what was going on, she realized that no one was working together, that she was responsible for a chemistry lab in which there was a whole bunch of chemists. And then she had a colleague, Jeff, who was over there responsible for a biology lab. So in terms of that design, make, test thing, Beth was responsible for chemists thinking, design, and physically making, synthesizing, and then handing it over to Jeff for testing. And when she started going around and asking people what they were working on, turned out no one was working on anything remotely like the same thing. So there was one dude, this guy, John, at one point he moved from one lab to another. So they go to clean out his cabinet, and he had 200 vials of compounds. And they said, John, what the hell does it have to do with anything? He said, no, nothing much. It just, I found these compounds interesting. So I went ahead and made them in case they'd be interesting someday. Now think about this. John is like a freaking brilliant dude, but none of these 200 advanced any program towards delivering a meaningful therapeutic into the marketplace. Then there was another guy who he had a good idea. It was like a Thursday afternoon. He'd done his work for the week. And he says, I'm kind of interested in this compound. It won't take me long to synthesize. I got it already figured out what it's going to look like, how to make it, what to mix here, what to heat there, Thing he hadn't counted on was that didn't take much time for him to think about it, design it, and then not too much time to synthesize it, make it. But when he handed it over to the biology lab, they had to invent a whole new set of tests. It was like 3 weeks worth of work to invent the tests that would give him data back. And it turns out on something that wasn't on any kind of critical path towards getting a therapy onto the next step. So Beth is like, oh, this is insane. This is insane. I have people doing all this crazy amount of work, and mostly it's just, someone does work, and then the idea just sits around waiting for someone else maybe to pick it up. So what does Beth do? She said, we got to stop this nonsense. She said, and you got to think about this. Beth is in no position to say, boss people around, Dennis do this, David do this, Ann do this, Jim do that. All Beth says is, look, let's have a conversation. Let's have a conversation. What's the conversation about? Let's have a conversation about what we think our priorities should be. What molecule are we trying to advance in the program? What part of the molecule do we still lack understanding that we have to figure out how to build up that part of the molecule? Of that, who can take different pieces of the design of that part of the molecule? Who can, and here's the thing, Beth wasn't trying to get to consensus. She wasn't trying to get to consensus. What she was trying to get was people to express fully in conversation their point of view. Now, Jim and I, we might not agree which molecule, or with Dennis and I, we may not agree which part of which molecule, but Beth just wanted it out there. So then they could say, look, we still have to do things one by one by one. That's how it goes. But we're not saying we agree. But now what we're doing is we're taking ideas and we're converting them into experiments. Let's say Jim argues vehemently, and not meanly, but makes a case vehemently that molecule A should be the first one to develop in the program. And Dennis says, and it's this part of the molecule that we have to really invest time in. We may not agree with him, but now at least we have a testable hypothesis. So what's Beth done? What Beth has done is she's, by insisting on establishing priorities, even if there's not agreement, but there is a prioritization. Now these ideas can be tested as they go through the system. Now a second thing happens now. Now that Jim and Dennis and me and Carl and Ann and Emily and everybody is trying to think in terms of, we got to get A done, then we got to get B done, then we got to C done. The biology lab, which is doing all the testing stuff, they're no longer some abstract entity way out there doing whatever they do, occasionally sending in a report with data. What they are is now they're a critical step. Because if we're trying to advance A through the system, we design a piece of the molecule, we make a piece of the molecule. Now we're sitting there saying, yo, biology, I need the report. Yo, biology, I need the report back. So now the priorities downstream are starting to set priorities upstream. And what that does is that invites not only collaborative conversation within the chemistry silo. It invites collaborative conversation within the biology silo, and then starts inviting collaborative conversation across the silos. And then as they start to have these conversations across the silos and within the silos, biology and chemistry, they realize, son of a gun, there are these other processes like purification. There's other processes like just getting the basic supplies and raw materials we need. So anyway, by this first act by Beth of saying, hey, let's have conversation so we can generate a list of priorities. Again, not agreement, but we're going to come with a list of priorities. And as we work them, we will discover if we have the right list or the wrong list. It allowed this cascade and this expansion of collaborative conversation for the purpose of collaborative creativity. Anyway, net, what's the result of this? So when this pilot started, it was taking plus minus 13 months to get a molecule from hit to lead where it can be developed further. When this cascade of collaborative creative conversation was initiated and took hold, that time went down to 6 months. The number of cycles of design, make, and test went from 60 down to 19. And not only did they get through the pipeline faster, but what they delivered onto lead development was just way better in terms of the quality of the molecules and the data around them that could be put into good use. Now, taking this, and again, I'm not going to spend any more time on this alignment externally. Now we're talking alignment internally. But in chapter 4 of my book, and I threw down a bit.ly thing here. So while I'm talking, I'll type in the link, bit.ly HVE_chapters. I think that should work. This is the same story I tell in the book about Pratt & Whitney, where they were taking like 4 years to have very expensive piloting of engine designs that kept losing contests. And when you take a look at what they did at Pratt & Whitney, it's the best story. Obviously it's more engineers and bigger scale and costing more money, but it's the best story about first establishing priorities and then building systems and flows of work through that system to go from 4 years down to 3, X number of engineering change orders down to half of that. And then on the pilot, winning the contract for the Joint Strike Fighter was like 3,500 jets, $10 million per engine, spare parts, maintenance, this thing and that thing. It's just like incredible. So anyway, let's see, nothing in the chat so far. So thank you, Carl, for the quote. Don't feel ashamed about interrupting over there. Anyway, keep on moving through things we need to do so that we can integrate the many pieces, the many contributions of individuals towards a common purpose. Next thing I want to emphasize is this idea of experimentation versus winging it. And you probably had this experience, Someone says, oh, yes, well, when we're well within the known space of our discipline, et cetera, we can do very controlled experiments. But what I do is cutting edge work, Steve. You got to understand, it's very cutting edge. And, it's more art than science. And it's sort of funny because I've heard that line. You probably have heard that line too, right? Where, someone says, well, you have to understand this is art, not science. It's like, dude, you're a freaking chemist, dude, you're, do that, gal, guy, whatever. You're not an artist. You're a computer science software engineer. This is engineering. But anyway, let me just for the next piece, the experimentation. I just want to offer that sometimes people are willing to diminish the power of doing a bona fide experiment, even when you're in science and engineering realm. And I just want to say, if you ever encounter that, just say, look, artists do science. And yes, there's probably a whole lot of science on mixing paints and that kind of thing, but this is what I mean. So let's pick a dude, Pablo Picasso. I think everyone would agree he's a world-renowned master artist. No question about this. What you're showing here is a picture of from the Pablo Picasso Museum in Barcelona. It's a painting he did. I don't know, it was like 13 or 14 or something. And he got some big, huge award for this painting. And actually, ironically, now that I think about this, the contrast between art and science and technology, I think he got an award for using art to portray science and technology or something like that. But the point is, he did this when he was like 13, 14. So you might be looking at this and saying, well, yeah, what do you expect? The dude was a genius. He was one of a kind. He was kind of like, the Mozart of brushes or whatnot, so what do you expect? So here's what I want to point out is that Picasso, yes, more talented than me. You saw my art in the beginning. I can do emojis, right? But he didn't start with this. This is where he ended up. And so here's it was a fascinating exhibit. Picasso had this huge masterpiece. This thing was the size of like 2 or 3, large screen TVs, being sarcastic there. But next to it was like the size of a piece of notebook paper. There was a series of paintings, little sketches and things. Now you notice here, what's this one? It's 3 people in a room. And you're looking at it, and it's like, well, what's going on in this room? You don't really know. All right, yeah, someone's in bed and there's other people standing by, but you can't really understand what's going on by this painting. And it's not clear Picasso did yet. But then, because the next painting, notice the subtle changes here. I'll flip back and forth. Notice these little things. Like the guy on the left, dressed in the dark, all of a sudden, where do we go here? Sorry, I'm going. The guy on the left, all of a sudden is an outreached hand. He said, oh, wait, what's going on here? Why is he reaching out a hand? It's sort of giving a hint. That hint is not in the first sketch. That hint is only in the second sketch. And notice also what Picasso does is in the first sketch, the person in the bed is looking at it, looking sort of landscape view sideways. And typically we don't make strong emotional connection with people when we're looking at them from the side. I mean, think about how often you've said to someone or someone has said to you, hey, look me in the eyes. I want to see you face on. I don't want to see you in profile, because profile is distance. Profile is an emotional separation. Face on, that's where we make the connection. So what does Picasso do between version 1 and version 2? There's the outstretched hand. That's a connection. He pivots the bed. He makes more of a connection. All of a sudden, that other character there versus the first one moves in tighter, and it seems to be holding something. So then we get on to the third sketch. And what do we see on the third sketch? We get a little more detail versus the second, right? By the time we get to the third sketch, we see that the figure on what you're seeing on the left here, not only is the outstretched hand, but there's looking in the, like this, like he's looking at a watch. Ooh, is that taking a pulse? The person on the right of our screen, all of a sudden you see, wait, she's dressed like a nun/nurse. And what's that in her arms? Oh, that looks like a child. And then now we're getting even more of a face on of the person laying in the bed. So we get to the masterpiece. Now, look, again, could I do this ever in my life, let alone 13? No, of course not. But neither could Picasso. What Picasso needed to do is he needed to experiment his way to the answer. And think about the number of times where we're under great stress and people say, oh, we've got a problem, which they haven't defined. We need to solve it. They haven't actually gotten all the stakeholders. Now we need a solution. We don't have time to experiment. Just one last thing on this art thing. Great book recommended. Go to my friend Jeff Bezos. He'll sell you a copy through Amazon. Monet in the Mediterranean, phenomenal book. And we tend to think of Monet as one of these, geniuses, but the thing about Monet, yeah, he was a genius, but he was an experimentalist too. And here's just one example. Yeah, Monet did these various trips to Venice, French Riviera, somewhere else in Italy. And he never set up one easel though. And here's an example where he set up 3 easels. Yeah, you can see it's the same scene, right? Same building. So what's the difference? He's got his 8 o'clock easel, he's got his noon easel, and he's got his 4 in the afternoon easel. Because what is he trying to do? He's trying to take his experiment and compress it down to 1 or 2 variables around lighting. And how does he do that? Perspective, it's the same. Depth of field, it's the same. Subject matter, it's the same. Time of year is the same. You can even see it with the little trees in the upper right-hand corner. So he's taken this very complex thing of creating a masterpiece, building off all the skills he's already acquired, and said, now I'm going to work on lighting. I'm going to work only on lighting. So anyway, that sort of ties us into experimentation and this whole idea of this incrementalism. Why does he do that? He does that because if you're trying to master your skills on depth of field and perspective and lighting and color choice and subject and location and material, watercolors versus oils versus whatever else, how do you even learn from it? That's just a gobbledygook mentally. You can't process that. So what does Monet do? He says, I'm going to get down to a single variable experiment. I'm working on canvas. I'm working with oils. I'm looking at the same building from the same location, same depth of field. The only thing I'm doing is I'm changing the time of day. That's it. That's it. Now, this conveys over. This conveys over when we see big technical problems solved successfully. Now, I think the phrase we now use is agile. And basically, what is agile doing? What is agile doing? Agile is saying, hey, when you got a big, hairy problem, don't try and solve it all at once. You can't solve it all at once. It's impossible. It's too many variables in play simultaneously, too many parameters being stressed from what's known to what's not known all at once. And here's an example, right? So when President Kennedy said, hey, we're going to send a man to the moon, return him safely to the earth by the end of the decade, wasn't like he said that in front of Congress in 1961 and Neil Armstrong said, all right, guys, when you're ready, just stick me on top of the Apollo and away we go. It's not how it happened. The way it happened was that NASA broke this big technical problem into a lot of small pieces. So you had your Mercury, you had your Gemini, you had your Apollo program. Within Mercury, you had your several flights of Mercury. Now let's just focus on this for the first one. What's the first flight of Mercury? Did they go to the moon and come back safely or not? No. Alan Shepard, he goes up, he comes down, 18 minutes, that's it. Now, and I'm saying that very sarcastically, because why was that? Because there was a lot to have to be developed just to figure out how to get a rocket to launch without exploding, how to get it to go and reach its apex, and then come back down and land safely, all the while being able to talk to the astronaut who's on top of this thing and have life support and communication. And it turned out that was enough. That was enough to validate on the first flight. All right, so with that validated on the first flight, what do? Then you get Gus Grissom on the second one. What does Gus do? Well, he goes higher and stays up longer, right? Because he takes advantage of everything that had been validated on the Alan Shepard flight and builds off of that validated layer and then ends on top of that. And we discover, there's the whole problem he has with the hatch, and you saw that in the movie and the right stuff and whatnot. But then you get John Glenn. And it's John Glenn on the third flight where he does, building off of what had been validated on flights 1 and 2. He goes up and he orbits. And why is that a big deal? Because in order for him to orbit safely, you all saw the movie Hidden Figures. It's very dramatic, but what's the dramatic tension in that movie? Figuring out how you come out of orbit without bouncing off the atmosphere and going into space for perpetuity, or coming into sharp an angle and burning up like a crisp. Right now, how could that be the dramatic tension in that movie? Because all the other stuff had been validated already, right? Because Alan Shepard and Gus Grissom had validated on their flights the takeoff, the communication, the life support, et cetera, et cetera. And so then we get to John Glenn. We say, John, don't worry. All that stuff, we got that stuff nailed down, man. They're coming back without burning up in the atmosphere. Worry about that. The other stuff, don't worry about. And this goes on. And again, I'm trying to rush through this, but we see in the Gemini program a similar thing. Many, many flights. And what does one flight have relative to the other? Each flight is an incremental increase in complexity based on what's already been validated. And then, just to wrap this up, as we get into Apollo is the same thing, right? Which is, it's not till Apollo 11 where Alan Shepard, Buzz Aldrin, and Michael Collins go to the moon, land safely, and come back. But what happens? Why do you have to go to Apollo 11 to get that? It's the same approach. It's the same approach, which is, what we got to do is we got to simplify the problems we're trying to solve at every single step. So what happens on Apollo 8? Frank Borman and his crew, they take off, they orbit the Earth, they head off to the moon, they orbit around the moon, they come back with no aspirational landing. But it turned out no one had ever flown that far, right? They'd flown long duration flights, et cetera, but never long distance. They needed to validate how you get to the moon and back safely. Then Apollo 9, that crew, they never went anywhere near the moon. What they did is, based on what was being validated out there with Frank Borman and his crew, they validated how you go from the command module to the landing module, back and forth, rendezvous, fly-in synchronization, this thing, that thing, right? Apollo 10, right, was still up to Neil Armstrong. What do? Taking all the stuff that had been validated so far on Apollo 8 to the moon and back. Apollo 9, in terms of the rendezvous and the flying in formation, et cetera, what do? They fly all the way to the moon, but that's been done already. They rendezvous with their landing module, but that's been done already. What do? They start landing towards the moon. That's the new thing. But they land on the moon? No, they stop. 47,000 feet before landing, they hit the punch back switch, and they come back and they come home. And I've heard, I don't know if it's true, but apparently in the equivalent of the 1968 equivalent or 1969 equivalent of a Post-it note, there's a Post-it note inside that said, "Dear astronaut, at this point, you're probably rather tempted to land on the moon. You've come a long way, 250,000 miles. By the way, we didn't give you enough fuel to land on the moon and come home. Choice is yours." Anyway, don't know if that's true, but it makes the point. Anyway, what we get with Neil Armstrong and Buzz Aldrin is when they get to the moon and they say so poetically, that's a giant leap for small step for man, giant leap for mankind. It was both poetic and in some regards true, right? Because what did they do that hadn't been done? What they did that hadn't been done was the last 47,000 feet down, land, walk around and come back. But once they'd done that, and again, I say that sarcastically to make the point, once they'd done that, everything else had been validated more or less, right? So anyway, to the point about making problems within that we can actually handle, we're really bad at handling problems which have a lot of variables in place simultaneously. And from experience, from observation, that when you've tried to solve problems, excuse me, when you've tried to solve problems when there's a lot in play all at once, it'd be like Monet, new building, new location, new lighting, new material, new media, et cetera, you get a mess. And the way you get to a good answer is validate a layer, work on the next one, validate that layer, add to the next one, boom, 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 boom. And I like this little picture here of the rockets going back to the V2 on the far left up to the Saturn V on the far right. Yeah, they're much more massive. They had to carry a lot more fuel and equipment. But I think in some ways they're representative of this accumulation of layered learning, validated learning that allows someone to go to the moon and return safely to the Earth at the end of the decade. So anyway, just looking, and guys, please use the chat if I'm not making any sense. I did have a couple of points I wanted to blow through to invite. So another thing is when we talk about issues of doing work in general or innovating more, and innovating under stress, I think the point I want to make here is to think in terms of this being a team sport, not an individual sport. And the folks who were popped into this coming out of the Lean community, maybe instead of the DevOps community, you'll like this example. But a bunch of years ago, I guess about 1985, General Motors threw up its hand in frustration. They had a factory out in Fremont, California. They couldn't run it for a stitch. It was record absenteeism. The quality was awful. The one thing they did well is hourly grievances against management. They were record setting in that. Union grievances against management, they were world class. They shut the plant down. It gets reopened as a joint venture, New United Motor Manufacturing, Inc., with the joint venture is a 50-50 Toyota General Motors. And the deal was General Motors contributed the factory, Toyota was going to manage the darn thing. And the punchline goes something like this, which is what was arguably the worst factory in the country became the best factory in the country by about every measure: quality, productivity, J.D. Power Awards, employee satisfaction. There was no dimension of metric that you would put on this factory where it wasn't best in the country, maybe number two, but best. It was huge transformation. And the punchline was, it was the only thing that changed was how management behaved, right? The management gap I referred to earlier, it was the same hourly employees. They were still UAW. 98% of the people who worked for NUMMI had worked for General Motors as union, hourly workers with union representation. Now, here's the thing. You'd think this was like some phenomenal incubator where General Motors, which had been getting its butt kicked, could have figured out what Toyota was doing in terms of managing the work of many, many thousands, many people towards common purpose. And if you know General Motors fortunes, I use that term with air quotes, right? What's the negative, the inverse of fortunes? They're suffering the last many years. Clearly, it didn't stick. Now, this is my assertion as to why not. See, Toyota looked at this NUMMI thing and said, man, this is a great place where we can teach people a team sport. of collaborative creativity, a team sport, of integrating the many, many pieces of people's intellectual, conceptual capacity towards common purpose. And so what Toyota did was they would send teams of Americans into NUMMI. They'd experience the system in all its holistic, highly integrated, dynamic, complex integrity. And then they'd leave as groups going to Georgetown, Indiana, West Virginia, up in Canada, eventually down to San Antonio, this place, that piece, as a team. They learned this as a team sport. And not surprisingly, those lessons transferred well because people understood how they fit into this larger system of collaborative creativity. What did General Motors do? They sent individuals. Yo, Kurt, come over here. Stop doing what you're doing. You go to NUMMI. You master what's going on in NUMMI. And what they do, they take poor Kurt and they stick him back where he came from in an environment which has none of the culture, none of the norms, none of the processes, none of the procedures they saw at NUMMI. And they do the same thing for poor Donald. Donald, you come over here from that other place. You go into NUMMI, spend a year or two. Now we're going to stick you back. Not connecting with Mark or anybody else, just on your own. Yeah, figure it out. Now, the reason I'm jumping up and down is I've seen this now with large enterprises which say, oh, gee, we need to learn to be innovative. What we're going to do, we're going to send some of our employees to a venture capital firm, a startup, a private equity firm, so they can internalize the ethos, the norms of what goes on in the innovation ecosystem. Now, there are some which say, you know what? There's probably something about the norms. There's probably something about the culture. There's probably something about the integrating. Let's talk more nerd-like on this thing. The social circuitry by which we integrate the many individuals towards common purpose. It's probably kind of a team sport going on there. So occasionally you'll see some folks sort of embedding or seconding their employees as teams to go off as teams, master what's going on there and come back as a team. But let me ask you this, how many of you seen this, whether it's your own organization or observe it of others, where Enterprise B says, hey, Nasir, what I want you to do is, as an individual, go to Sequoia Capital. They're in a different industry. They're in a different part of the country. They do different things. But you go as an individual, you come back to behemoth enterprise that we are, and you convert behemoth enterprise. It's like, good luck, Nasir, right? Is that going to happen? I don't think so. So anyway, that's another warning here is we start thinking about building capability. That was the theme of this rant was, are we building capability as a team effort where we actually think about developing people and how they act and integrate and coordinate and collaborate with other people. And we have this idea of coherent teams inside of coherent innovation units. We just say, oh no, Nasir, you go figure it out and tell us what's going on. Yeah, good luck with that. Anyway, just looking at the time here, I just want to land on one more theme, and this is the one of creating a protected space. There was another point I wanted to make, but I'm going to run out of time. So again, there's another theme I wanted to get to. May not have time. Center out, BS top down. And again, if you go to our webpage, we got a little webinar which doesn't blow through out. But I just want to talk about this idea of creating protected space. Y'all have probably heard of the idea of a skunk works, Lockheed Martin. Now, why did Lockheed Martin need skunk works? And the first answer is because it's like, well, look, Steve, you got to understand Lockheed Martin at different points in its history, it was developing this really wildly outrageous technology. And because it was developing wildly outrageous technology, it had to create a space to develop that technology. That in part is true. There's nothing wrong in that statement, but there's something else. And I encourage you as you take a look at these different pictures, is that this technology was meant not only to be kind of really cool technology, but to solve a problem which previously didn't even exist, let alone have to be solved. So I'm going to scroll down to the third plane, going from top to bottom, the Blackbird, the SR-71. What was the problem there? Is that coming out of the Second World War and the development of intercontinental ballistic missiles and nuclear-tipped warheads, people start getting really pretty worried. It's like, holy crap, how many of these things does Khrushchev have and where is he pointing them? And the answer was pre-satellite, of course. No one had a clue. No one had a clue. Now it makes it really hard to figure out how you budget, how you train, how you equip, et cetera, et cetera, et cetera, if you don't know where Mr. Khrushchev has his missiles pointed. And so Lockheed Martin was tasked with the mission of creating a plane that could do the overflight. Now you start thinking about it. No plane had ever had to fly, let's say from take off in Turkey and fly way over towards the North Pole and make a U-turn. The turning radius on this plane was like 3,000 miles. I mean, it was insane, right? That kind of mission had never existed for an airplane. I mean, this was definitely not Orville and Wilbur Wright and, 18 seconds at Kitty Hawk, right? So not only did Lockheed Martin have to have a place where the technology could be invented, the mission of the plane had to be up for invention too. That whole issue of horizons and problems and stakeholders, so protected space. The other example I want to give you, and then I'm right at the top of the hour, is Toyota and General Motors both stared down the challenge, the opportunity, I suppose, of doubling the fuel efficiency on cars. General Motors came out with the Volt, and I mean, to say this diplomatically, I don't know, the Volt, I don't know, sucked. So, sorry. What I mean by this is that if you look at the architecture of the Volt, there's nothing particularly interesting about the architecture. Basically, what they did is they did the plug and play. Internal combustion engine comes out, electric motor comes out in, gas tank goes out, battery goes in. And then, oh, by the way, because the battery's not so good, when the Volt was invented, we put a little Black & Decker Smith & Wesson generator in the back to keep recharging the battery. Not a very complicated architecture, mechanical devices, 10 million lines of code. My friends say mostly for the entertainment and the navigation system. At the same time, Toyota comes out with something called the Prius Hybrid. Now, the Prius Hybrid is a way more sophisticated situation because you got your electric and your internal combustion in parallel with lots of power management flows back and forth, and his measure of complexity and sophistication, 100 million lines of code versus the 10 million when it comes out. Since that time, Toyota's taken, General Motors has canceled their their whatever it is, sold a piddling number of units, closed the factory, fired the workforce. Toyota has put their hybrid system on like 36 different models, 20 million units sold. And you say, well, what was the difference? Well, part of the difference was Toyota went ahead and for when they were looking at this problem, they said, well, what do we know about this? They said, I don't know. And they said, well, how are we going to solve this problem? They said, I don't know. And they said, well, can we depend on our existing systems, norms, processes, enterprise processes, et cetera, et cetera? I said, yeah, probably not. And so Toyota created something what they called the red room. It was called the red room. It was a room. It had red carpeting. If it had purple carpeting, it probably would have been the purple room. But it had red carpeting. It was the red room. Well, basically, what was key to the red room is they said, Tom, Mark, Azrael, you go into the red room and do what is necessary to solve the problem of doubling fuel efficiency. And they did. And they did because they were able to create new mechanisms for solving the problem with the various stakeholders who may not have been part of solving other problems. So they got into with Mitsubishi Electric, a collaboration on power circuits. They got in with a company that did the electric motors for factory automation because they knew how to do these things, rugged, robust, reliable, in volume. These were relationships that never would have existed outside the red room because they were never necessary. Anyway, Jim, I think I'm at the top of the hour here. So let me just invite people back to where we started and where we're ending. Where we started is that when you're under a lot of stress, the reason you're under a lot of stress is you may have a new problem, but you certainly don't have a solution. The reason you don't have a solution is because you haven't figured out yet how to manage the contributions of many, many people towards that common purpose. And what I wanted to try and do today is get through, at least partially through this list of things you can do to better integrate. So align on the external problem, make sure you got internal alignment, experimentation versus winging it. Look, if Monet could do science, you can do science. Make sure the problem is at the right scale, to the moon and back. Make sure that you've got, you're developing your talent on these skills and not individuals and hope they're going to transform behemoth enterprise, protected space. And anyway, if anyone's got any want to continue the conversation, here's where to reach me, how to reach me, etc. Got the website, and Christmas is coming up. Buy the book for your friends, your family. They'll appreciate it. I mean, I will if you do. So I'm sure they will too. But anyway, Jim, thank you very much for the chance to rant and ramble today. And I hope at least something I said was entertaining and maybe even a little bit useful to everybody who spent the hour. Thank you.
Of course, thank you very much, Steve. We do have a couple of comments in the chat here. And if anybody, I think we have time, maybe just a couple of minutes if anyone wants to ask a question before we wrap this up. But somebody did say, oh, sounds like what happened with DHS initially. DHS, I'm assuming Department of Homeland Security.
Yes. It was specifically when he was talking about like pulling a bunch of different people and putting them into one spot and be like, it's like, hey, take this person, dump them all together and kind of see what happens in that sense. When he was talking about the factory itself, and I was just talking about like the idea of like, kind of pulling all these folks together and expecting this sort of cohesive thing to happen. Never really did happen, but ultimately I think things have gotten much, much better over the last few years.
Right. And again, my bet is that it's because they realize, oh, we got to get a team together with all that cross functionality, but make it a coherent team that's anchored onto a problem and not just a bunch of people randomly together. Yeah, excellent.
And lots of great sessions, great talk. And then one other comment from Kurt, big missions at AFTIC as well at the start of the nuclear age.
Yeah, you were talking about the changes of how how folks had to flex to go to different things and the different mission space, and saying, hey, this is something that's never been done before. AFTAC, if you don't know, is the agency that's been built to monitor nuclear treaties. Kind of started in the 50s, but it was again something that folks had never done, and try to build a global sensor network in order to figure out, hey, are people paying attention and doing what they should be doing? So
yeah, that's excellent. Yeah. Whatever you had after the Treaty of Versailles to count people's battleships probably wouldn't apply for nuclear tipped missiles. Yeah, excellent point. Fantastic.
Awesome. Thank you for those comments, Kurt.
Sure.
All right, everyone. Yeah, we are out of time. I know a lot of us need to get back to work, me included, but I do want to thank everyone for attending today. Thank you again, Steve, for leading such a great talk. And a final thank you to our sponsor, Incredibuilt, for supporting the community. We'll have this recording available for everybody at mlotgroup.com later this week. I hope you all have a great rest of your day, and I hope to see you at the next event.
Yeah, and keep being brilliant, people. The world needs it. Thank you.
Cool. Thank you, Steve.
You bet.
See you, everybody.